Hello, my name is DJ, and today I am going to be going through the AMC 10B 2006, and I'll be solving every problem from problem 1 to problem 25. And so let's get started. First problem: what is minus 1 to the first power plus minus 1 to the second power all the way to the minus 1 to the 2006th power? So just like write it out. It's minus 1, and then it's plus 1, and then it's minus 1, and then it's plus 1 all the way to this is plus 1, so it's plus 1. So if you separate it by 2, then these all come to 0, 0, 0, 0, and then plus 1. This also comes to 0, so the whole thing is added up to 0. So the answer is 0, C. And problem 2, for real numbers x and y, define x spade y equals x plus y, x minus y. This is actually x squared minus y squared. 3 spade 4 spade 5. So 4 spade 5 is 16 minus 25, so it's minus 9. Minus 9. And then 3 spade minus 9 is 9 minus 81. 9 minus 81, which is 9 minus 81, it's minus 72. This is A. And then problem 3, a football game was played between the two teams, Cougars and the Panthers. The two teams scored a total of 34 points, and the Cougars won by a margin of 14 points. So there's 14 points, and it's a total of 34 points, so it's 10 points, 10 points. And then the Cougars won, so this much is the Cougars, and this much is the Panthers. How many points did the Panthers score? It's this much, so it's 10. It's 10 points, it's A. Problem number 4, circles of diameter 1 inch and 3 inches have the same center. The smaller circle is painted red. This is painted red. The portion outside the smaller circle and inside the larger circle, so this much is painted blue. What's the ratio of the blue painted area to the red painted area? So we're talking about ratios here, right? So the actual length of the diameters or the radiuses, they don't matter. So let's just say that not the diameters, but the radiuses are 1 inch and 3 inches respectively, because that would just leave the same ratio as if it had been a diameter. So the radius of this is 1 and the radius this is 3. So blue would be 9 pi minus pi, which is 8 pi, and the red would be just pi. So it's 8 pi over pi is pi. This is 8, so it's 8, it's D. Problem number 5, 2x3 rectangle and 3x4 rectangle are contained within a square without overlapping any point, and the sides of the square are parallel to the sides of the two given rectangles. What's the smallest possible area of the square? So for this one, there's a 2x3 rectangle, and then there's a 3x4 rectangle, like this. And then we have to put these two together to make it the smallest possible area of the square. So for that, we can just make this right here, so that this would be 3 and this would be 4. And so one side would be 5. So this whole side will be 5. So the smallest possible area is 5 squared, which is 25. So it's 25, it's B. Problem number 6, a region is bounded by semicircular arcs constructed on the side of a square whose sides measure 2 over pi. The perimeter of this region, so they're talking about this one here, and this one here, and this one here, and this one here. So the perimeter is 2 times the circumference, because there's 4 semicircles, 2 times circumference. This is 2 times 2 over pi times pi. This is 4. So the perimeter is 4. And problem 7, which of the following is equivalent to this thing when x is less than 0? So this one, we could say that this whole thing is the same as, that's the same as root x over, and then it's x minus x plus 1 over x. It's root x squared, which is x. No, it's the absolute value of x, but it's x is less than 0, right? So this is equal to minus x. With minus x, it's A. Problem 8, what's the area of the semicircle? So we're trying to get the area of this whole thing, but the area is 40, the square's area is 40, so this is 2 root 10, and this is 2 root 10. That means that if we put a line from the center to here, just like this, then then this will have root 10, and then 2, and then 1 to 2 to root 5, so it's 5 root 2. Area of the semicircle, it's 1/2 times 5 root 2 square pi. This is 25 pi. So it's 25 pi, so it's B. And problem number 9, Francesca uses 100 grams of lemon juice, 100 grams of sugar, and 400 grams of water to make lemonade. There are 25 calories in 100 grams of lemon juice. There's 25. And then 386 calories in 100 grams of sugar, 386 calories. Water contains no calories, so in 600 grams of lemonade, there will be 25 plus 386. This is 411. 411 grams. No, 411 calories. So in 200 grams, that would be a third of this here. So 411 divided by 3, 1, 3, and 7. It's 137 kilocalories. So 137 calories are in 200 grams of lemonade. It's B. Problem 10 is in a triangle with interior side length. One side is 3 times as long as the second side. So in the triangle, one side is 3 times as long as the second side. So if there's a triangle, then it will be 3A, and the third side would be 15. The greatest possible perimeter would make it so that the 3A is the greatest. So rather than this kind of picture, it would be 3A here and 15 here. So 3A will be less than A plus 15, 2A will be less than 15, A will be less than 7.5, and it's the integer side length, so it would be, so A would be 7, and so it's 4A plus 15, that's the perimeter. So it's 28 plus 15, which is 43. So problem 10, it's A. Problem 11 is the 10th digit in the sum 7 factorial plus 8 factorial plus 9 factorial plus 10 factorial all the way to 2006 factorial. So from here you have to notice that 10 factorial plus 11 factorial plus 12 factorial all the way up to 2006 factorial, these all have tens digits of 0 because they have two fives, at least 2 5s in all of here, so the tens digits are all going to be 0. So with that in mind, we just have to do 7 factorial plus 8 factorial plus 9 factorial. And if we take out the 7 factorial, then it becomes 7 factorial, 1 plus 8 times 9, so it's 7 factorial times 1 plus 8 plus 72, so it's 7 factorial times 91. 81. 7 factorial times 81, and the 7 factorial itself would be 1, 2, 3, 4, 5, 6, 7, and then here we have to, and then here this would be 10 times, so we've got out to 10, and then 3, 4, 12, 12 times 6, 72, 72 times 7, 14, 504, so it's 5040 times 81, so the tens equals 4 times 1. It's 4. So it's 4, it's C. Problem 11, the answer is C. Problem 12, the lines x equals 1 over 4y plus a and y equals 1 over 4x plus b intersect at the point 1, 2. What is a plus b? Then from this one, we can say that the lines, so they intersect at 1, 2. So we just put 1, 2 into both of these. That would get us 1 equals 1/2 plus a, so a is 1/2, and 2 is 1/4 plus b. B is 7 over 4, and so a plus b, the sum of these would be 9 over 4. So for problem 12, it's E. 13, Joe and Joanne each bought 12 ounces of coffee in a 16-ounce cup. drank 2 ounces of his coffee and then added 2 ounces of cream. So this means that there is 2 ounces of cream for 12 of the whole thing. And then Joanne added 2 ounces of cream and then stirred it and then drank 2 ounces. So that means she had 2 ounces over. So the ratio of the cream to the whole would be 2 over 14 since she added 2 to the 12 that she had previously. So this is 1 over 7. And so the amount of cream in Joe's coffee to that in Joanne's coffee, Joe has 2 ounces, and then Joanne, she has 2 times 1 over 7. No. Yeah, she has 2 times 1 over 7. So this has to be 12 over something, right? So 2 times, yeah, so this has to be 12 over something. So in order to get this something, this is 12 over 7. Yeah, so Joanne has 12 over 7 ounces. What's the resulting ratio of the amount of cream in Joe's coffee to that in Joanne's coffee? So it's 2 over 12 over 7, which is 6 under 7. So it's E. From 13 is E. 14, let A and B be the roots of the equation x squared minus mx plus 2 equals 0. Suppose that A plus 1 over B and B plus 1 over A are the roots of the equation x squared minus px plus q equals 0. So if A and B are the roots of the equation x squared minus mx plus 2 equals 0, then A plus B is, let's write this, A plus B is m and AB is 2. And then what is Q? So Q is the multiple of these. So A plus 1 over B times B plus 1 over A. This is AB plus 1 over B times AB plus 1 over A. This is AB under AB plus 1 squared. So AB is 2. So if we put that in here, then this would equal 2 plus 1 squared. So this is 9 over 2, which is same as D. So problem 14, it's D. 15, rhombus ABCD is similar to rhombus BFDE. BAD is 60 degrees. So since this is 60 degrees and this is similar, so we can say that this is also 60 degrees, which means that if we put a line through here, then these 2 points would trisect CA. And so the area of BFDE, that's this much area, this is 1/3 of ABCD. And the area is 24, right? So it's 1/3 times 24, so it's 8, so it's C. Number 15 is C. Number 16, leap day, February 29, 2004 occurred on a Sunday. What day of the week will leap day, February 29, 2020 occur? So leap day, February 29, occurred on Sunday, so 2004. 2004, March 1st. So the March 1st of 2004. This is one day after Sunday, right? So it's Monday. And then on 2005, this is a normal year, not a leap year. So let's move this whole thing back a little. And so if it's 2005, then it would be plus 1 day, Tuesday, and then plus 1 day. 2006 would be Wednesday. 2007 would be Thursday, and then 2008 that would add 1 more day, so it would be skipping 2 days. So Thursday, Friday, and then Saturday, and then same thing, Saturday. Yeah, let's move this over here. 2008 is Saturday, 9, 10, 11, 12, 13. No. Let's move Saturday closer. These things closer. This whole thing closer. Yeah. 8, 9, 10, 11, Saturday, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's Saturday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, and then skip Wednesday and Thursday, Friday, Saturday, Sunday, skip Monday, Tuesday, Wednesday, Thursday, Friday, skip Saturday, Sunday. So 2020, March 1st equals a Sunday. So February 20, so it's one day before that. So February 29th, this would be one day before, so it's Saturday. So it's Saturday, it's E. Problem 17. Bob and Alice each have a bag that contains one ball of each of the colors blue, green, orange, red, and violet. So Alice randomly selects one ball from her bag and puts it into Bob's bag. Bob then randomly selects one ball from his bag and puts it into Alice's bag. What is the probability that after this process the contents of the two bags are the same? So there's one of each. So there's one of each color, right? So it doesn't matter what ball Alice selects. Bob will have two of the same color and then four of different colors. So for the contents of the two bags to be the same, Bob also has to pick one of the two same ones. So the probability is he has a total of 6 balls, and then he has to pick one of the two, so it's 1/3. So it's 1/3, it's D. And problem 18, let A1, A2 all be a sequence for which A1 equals 2, A2 equals 3, and AN is AN minus 1 to AN minus 2 for each positive integer n is greater than 3, and is greater or equal to 3. So if A1 is 2, then A2 is 3, then it's 3/2, then it's 3/2/3, which is 1/2. And then it's 1/3, and then it's 2/3, and then it's 2 again, and then it's 3. So it's this much that's being a cycle. So A 2006. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to this would be A 2004. Since 2004 is the closest integer to 2006 that's divisible by 6, and then this is 2005. This is 2006. So A 2006 is 3. Therefore, it's E. Problem 19. A circle of radius 2 is centered at O. A square OAB has side length 1. Sides AP and CB are extended past B to meet the circle at D and E, respectively. What's the area of the shaded region in the figure, which is bounded by BD, BE, and the minor arc containing D and E, connecting D and E. So what we need is two lines from D to O and from O to E. And so yes, so since this would be side length 1, 1, and 1, but the radius is 2, so this would be 30 degrees. The radius is 2, so this would be 30, 30, and 30. That must mean that the area of this is 1/3 of the area of the quarter circle, right? So the area of ODE, area of the fan, I forgot what you call this, the fan ODE, this would be 1/3 times the quarter circle, so it's 1/4 times 4 pi, which is 1/3 pi. And then the shaded region, this would be 1/3 pi minus, so we'll have to divide this into 2 again, and so we'll have to subtract 2 of these. So minus 2 of this much is, how much is this? So if this is √3 and this is 1, so this is √3 minus 1, let's write that in black. Root 3 minus 1. So it would be 2 times 1/2 times root 3 minus 1 times this much is 1, so the height is 1. So these two cancel, so 1/3 pi minus root 3 minus 1. This is 1/3 pi plus 1 minus root 3. So it's 1/3 pi minus, no, it's not this one then. It's 1/3 pi plus 1 minus root 3. So it's A. The answer is A. Problem 20, in rectangle ABCD, we have A equals 6, minus 22. P 2006, 178. D is 8, y for some integer y. So if we draw, then we can approximate. So 6, minus 22 would be somewhere here. 2006, 178 would be somewhere over there. And 8, y would be somewhere on this line. And so if we try to get what connects these two, then this is 6 to 2006, right? So this much is 2000, and it's minus 22 to 178. So this much is 200. So it's 1 over 10. Y equals 1 over 10 x plus blah blah blah. And then to this one here, it would have to go down under. Oh, so it will be going like this to this point, so that this could be a right angle, and then that would make this 1 to 10, but the actual length is, this is 2, right? Because this is 6 and this is 8, so it's 2 difference. So this is 2, that must mean that this is a 20 difference. So it's minus 22 minus 20 equals minus 44. So y equals minus 44. And then what is the area of rectangle ABCD? So let's see, if this is 2000 and this is 200, then by Pythagoras we can say that this is 200 times root 101. And then same thing here, this is 2 root 101. So 2 root 101 times 200 root 101. This would be 400 times 101. So it's 40400. It's E. And problem 21. For a peculiar pair of dice, the probabilities of rolling 1, 2, 3, 4, 5, and 6 on each die are in the ratio 1 to 2 to 3 to 4 to 5 to 6. What is the probability of rolling a total of 7 on the 2 dice? So on the 2 dice, you could roll, to get a 7, you could roll 1 and 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, and 1. You might think that these are the same, and you could view them as being the same if you don't care about like the order of the dice. But then this time I'm gonna be considering the order, and so it's 1, 2, 3, 4, 5, 6. So the total amount is, when you add these all up, it's 21, right? So considering order, it's 21 squared, and then to have 1 and 6, we have there's 1 and there's a 6, so it's 1 times 6 equals 6. This, and then for 2 and 5, you have 2 times 5, so it's 2 times 5 equals 10. This is also 3 times 4, so equals 12, and then this is multiplying, so it's the same, 12, 10, and 6. So it's 6 plus 10 plus 12 plus 12 plus 10 plus 6, which is 21 squared, and then you've got, what have you got? 28 plus 28, so it's 54. So, no, 56, not 54. It's 56 actually. So divide this by 7, and then we got 3 times 21, and then 8, which is 8 over 63. 8 over 63, it's C, therefore it's number C. Problem number 22. Elmo makes N sandwiches for a fundraiser. For each sandwich, he used B globs of peanut butter at 4 cents per glob and J blobs of jam at 5 cents per blob. I really like the units of the peanut butter and jam here. The cost of the peanut butter and jam to make all the sandwiches is $2.53. Assume that b, j, and n are positive integers with n is greater than 1. What is the cost of the jam Elmo uses to make the sandwiches? So for each sandwiches, he used b globs and j's blobs. So the total amount of that he would use is n sandwiches times 4 cents per glob, so it's 4b plus 5j. This is $2.53. But then since these aren't cents, I'll just make it 253. And this is 11 times 23. So either 4b plus 5j is 11 and n is 23, or 4b plus 5j is 23 and n is 11. If 4b plus 5j tries to be 11, then this is not possible if b and j are integers. So this is ruled out. If it's 11 times 23 and 4b plus 5j is trying to be 23, then j is 23 plus 11. Then j would be 10, 15. This would be 15, and this would be 8. Yes, so b would be 2, and j would be 3. And so n is 11. So the cost of the jam Elmo uses is cost of jam. This is n times 5j. This is 11 times 5 times 3. This is 165 cents equals $1.65. So it's D. Problem 23. A triangle is partitioned into 3 triangles and a quadrilateral. What's the area of the shaded quadrilateral? For us to get this, then we have to first make a line from here to here. Oh no, this is weird. This is weird. Yeah. Let's just make this line. And then since these two areas are the same, that must mean that these two lengths are the same. So if this value is a, then this must be a plus 3. And also, since these two is 3 to 7, then that must mean that the side lengths are also 3 to 7. So a to a plus 3 equals, a plus 3 plus 7, because there's this one here too. So it's a plus 10. This is 3 to 7. So 7a equals 3a plus 30. 4a equals 30. A equals 15 over 2. So what is the area of the shaded quadrilateral? 2a plus 3. This equals 15 plus 3 equals 18. So it's D. Problem 24. Centers of 1P have radii 2 and 4 respectively and are externally tangent. Points A and B on the circle, center O, point C and D on the circle, center P such that AD and BC are common external tangents to the circles. What's the area of the concave hexagon AOBCPD? So for this one, they have radii 2 and 4. And they're externally tangents. So let's try to connect these here. Connect like this. Straight line. And then here too. That would make this part 2 and this part 2, this part 2, this part 2. And so since the radii is 2 and 4, this length must be 6. So this much is 6. And so this triangle would be like 6 and 2, and this would be 4 root 2. And so this is 4 root 2, this is 4 root 2. And since this is double the area of this, so we have three of these rectangles in AOBCPD. And it's because there's this one right here, and there's this one right here, and then these two combine to form another of the same area. So it's 3 times 4 root 2 times 2. So this is For 12 root 2 times 6, it's 72 root 2. No, it's not. 12 root 2 times 2, which is 24 root 2, so it's B. And our last problem, problem 25. Mr. Jones has 8 children of different ages on a family trip. His oldest child was 9. So he has 8 children, but his oldest child is 9. So his children are 1, 2, 3, 4, 5, 6, 7, 8, 9 years old in age. But then we have to erase one of them here. And look, Daddy, that number is evenly divisible by the age of each of us kids. That's right, replies Mr. Jones, and the last 2 digits just happen to be my age. So from here, logically, the only 2 numbers that could be taken out is 5 and 7 because they are the only big prime numbers that don't have other multiples. And so let's try taking out 5. No, let's try taking out 7 first. If it's only 1, 2, 3, 4, 5, 6, 8, 9, then the total, if 7 is not there, then the total is 1, 2, 3, 4. No, then the least divisible. So the least common multiple would be 9 times 8 times 5, which is 360. And to make 360 into something, then we would have to, this is not possible, since 360 can't be made into a 4-digit number in which each of 2 digits appear 2 times. So that must mean that it's 7 is here and 5 is not. So the LCM of this one must be 1, 2, 3, 4, 6, 7, 8, 9, 7 times 8 times 9. This is 72 times 7, 4, 500. So it's 504. LCM is 504. So this could mean 5544 because this is 504 times 11. So this would be the number on the license plate, and the following is not one of the age of one of Mr. Jones' children. That would be the missing 5. So it's 5B. Thank you for watching.